The last section in this chapter is dealing with modeling. And so what we're talking about with modeling is taking information, points, tables of data, and then using that to write either an exponential function or a power function. So we essentially do three things in this section. We take 2 points and use it to write an exponential, we take 2 points and use it to write a power, and then we take a set of data and put it into our calculator and make our calculator give us a regression model. I'm not going to go through the calculator piece with you because that's the easiest of the three pieces. That is just entering things in your L1 and your L2 and finding the regression. What I am going to go through is how do you do it by hand, one of each. So that's what you're going to see right up here. We have two problems. One we're going to work with exponential, one we're going to work with power. Now the nice thing about these problems is the general equation, the y equals a b to the x or the y equals a x to the b, will be on your test or your quiz or whatever you're working with. Your job is to then take the information, put it in there, and be able to figure out what a and b are. So we're going to start with the exponential one, and you can see the equation for exponential, y equals a b to the x. You're going to take these 2 points and plug them in for x and for y, and you're going to end up with like a system of equations. So if I take the point 1, 4, and I put it into my exponential model, it will be 4 equals a b to the first. And then if I put the other point into a exponential model, it would be 12 equals ab squared. What you want to do is you want to work with either one. I tend to work with the one that had the smaller numbers, and you want to solve for a. So in this particular problem, if I want to solve for a, I'm going to divide both sides by b. So I have 4 over b equals a. Now what I'm going to do is I'm going to take this 4 over b and I'm going to substitute it in for a. So you're doing a system of equations where you're using the substitution method. So I'm going to write it as 12 equals 4 over b times b squared. I'm going to simplify with exponent rules. You're always going to have the same variable, one on top, one on bottom. So I'm going to subtract exponents. I get 4b. And then I'm going to divide by 4 to figure out that b is 3. Once you know what b is, then you're going to take that information, plug it into what you substituted originally to figure out what a is. So that means that a is 4/3. And then to finish the problem, you want to take your a and take your b and put it back into your model. So your final answer is actually a model that has everything filled in except for x and y. So my final answer for this one will be y equals, I'm going to replace a with 4/3, and I'm going to replace b with 3. And you can either put it in parentheses or you can put a dot to signify multiplication. Or you can put the 4/3 in parentheses. And that should be an x variable. I wrote b. You want to have 4/3 times 3 to the x power. That is writing an exponential model, and it's always the same process. Take the 2 points, put them one at a time into your model, solve one of them for a, do a substitution method so I can figure out b, and then sub back in to find a again. The second one is using the power model, and it will tell you in the directions when you're doing this problem which model to use and what the general form is. So now I'm going to take my points, 5, 12, and 7, 25, and put it into a power model. So my first one, when I take that first point, is going to look like this. It's going to be 12 equals a times 5 to the b. And my second one is going to be 25 equals a times 7 to the b. Again, I'm going to solve this system by getting a by itself. So I'm going to divide both sides by 5 to the b. So 12 divided by 5 to the b equals a. And I'm going to substitute that in for a. So I have 25 equals 12 over 5 to the b times 7 to the b. What you want to do is take both pieces that are to the b power and write it as a single fraction. So you have 12 times 7/5 to the b. Since it was 7 to the b over 5 to the b, that is the same as saying this quantity 7/5 all to the b power. We're going to divide by 12. At this point, because I'm going to get a decimal, I'm going to kind of carry it in my calculator. So first thing I want to do is pull up my calculator and take 25/12. I'm going to move my calculator over a little bit so you can see my work here. So I've got 25/12. So 2.083 approximately. And that equals 7/5 to the b. And then I have to solve an exponential. So this is using what I did the section before, which is using logarithms to solve an exponential. So I'm going to take both sides to the base, log base 7/5. So I'm going to take log base 7/5 on this side and log base 7/5 on this side. I can't really put it in there, but there's going to be a log base 7/5 there. On the left, I'm going to have to do change of base, so it's going to be the natural log of this 2.083 that I had divided by the natural log of 7/5, and that is going to equal b. So the nice thing is on my calculator, I'm going to move it back over so I can see what I was doing. I already have a 2.083, so what I'm going to do is I'm going to take the natural log of the answer. So I hit second and the little negative sign. So that's going to take the natural log of the 2.083, and I don't have to worry about rounding it, divided by the natural log of 7/5. So there's my b value. It is 2.181 approximately. Then I'm going to take that b value and I'm going to put it right there to find a. So my a value will be 12 divided by 5 to the 2.181. So I'm just going to hit second and the negative sign again. I need my caret there. 5 to the 2.181. It'll do it for me. So there's my a value, 0.358 if I got 3 decimal places. As you can see, solving or writing a power model is definitely more involved than writing an exponential model because it uses logarithms. So now I know A, I know B. My final step is to just put them back into my original model. So my original model, when I put them back in, will be y equals A was 0.358, x to the B was 2.181. You should expect a little bit messier answers with power. So again, both of them, you'll be given the general model when you start the problem. You're going to put your points in for x and y, and you're going to create a system. To solve the system, we're going to solve for one of the letters. I kind of like to be consistent. I always like to get a by itself, substitute that into the other equation, simplify. The power models are a little more involved because you do have to use logarithms in order to solve. You have to use a logarithm that's usually to a pretty strange base as well. If you can do these two things, as well as enter data into your calculator and do a power regression, then you'll be able to do everything that's on your test from this section.